So now let's see, as a data scientist, how can we use a Poisson distribution, and where can we use, and all those fundamentals we'll see. So Poisson distribution is a probability distribution that describes the probability of a given number of events occurring within a fixed interval of time or space. Given the average rate of occurrence, it's constructed based on the following assumptions. One is the events occur independently of each other. Very, very important assumption. The events occur independently of each other. And second, the probability of an event occurring in a given time interval is proportional to the length of the time interval. And the third, the rate of occurrence of events is constant over time. So the Poisson distribution is constructed by defining the parameter lambda as the average rate of occurrence of events within a fixed interval of time or space. So the probability of observing X events in that interval can be calculated using the below formula. We call this as a Poisson's probability mass function. Probability mass function. So in this, you can clearly see X is equals to, where capital X is the random variable representing the number of events. It could be number of customers, it could be number of no insurance policies, it could be number of events. So that's why we call it as a random variable representing the number of events in this case. Then small x is the number of events, and then E. E is the mathematical constant approximately equal to 2.71828, and x factorial is the factorial of x. So don't get confused with the capital X and small x. Capital X is the random variable representing the number of events, and small x is how many number of events are there. Okay, I will, if you're still confused, I'll show you the graph one more time so that it will be clear for you. See. Capital X is number of customers. Small x is 0, 2, 4, 6, 8, 10, 12, 14. That's it. Simple. What is there? Okay. So that's what E is equals to 2.71828, and then x factorial is the factorial of x. So the Poisson distribution was first introduced by French mathematician Poisson, as we have discussed earlier. So this one has numerous applications in various fields, including physics, engineering, finance, and biology. So one of the key assumptions, I'm repeating one more time, one of the key assumptions of the Poisson distribution is that events occur independently of each other and at a constant rate, which makes it a useful model for rare events that occur randomly over time or space.